Students, now I am explaining the next problem on the graphical presentation of a linear programming problem. So you have an objective function like this and the constraints here. So you have constraint 1, 2, 3 and 4, and the fifth is a non-negativity restrictions, that is you have to have x1 and x2 greater than or equal to 0. Now coming down to the first constraint here, the inequalities are converted into equalities, that is x1 plus x2 is equal to 10. Now when I put x1 to be 0, so it will be 0 plus 2x2 is equal to 10. So solving for 2x2 is equal to 10, so x2 is equal to 5. So when I put x1 to be 0, x2 is 5. Now let us put x2 to be 0, so x1 plus 2 into 0 is equal to 10. So here it is x1 is equal to x1 plus 0 is equal to 10. So x1 is equal to 10. So here if I put x2 to be 0, I get x1 to be 10. Now the second constraint is x1 plus x2 is lesser than or equal to 6. So I am converting it into equality. When I put x1 to be 0, so x2 is equal to 6. So similarly, if I put x2 to be 0, x1 is 6. Now coming down to the third constraint we have. So here we have constraint to be little different. So here the constraint is x1 minus x2 lesser than or equal to 2. When you convert it into equality, it will be x1 minus x2 is equal to 2. So here if I simplify this, it will be x1 is equal to 2 plus x2. So here we identify different values, say for example 4 to 5 values for the constraint here. Now hypothetically what we can do is we can take any values. So I will start with 2. So if x1 is equal to 2, here if x1 is equal to 0, if x1 is equal to 0, x2 is x1 is 2, so it is x1 is equal to 2 plus 0, which is equal to 2. So here I will identify range of values. Now here x1 is equal to 2 plus 1, which is equal to 3. So this is how we do. If x2 is equal to 2, then it is 4. So here x1 is equal to 2 plus 3 is equal to 5. So this is how we arrive at the values here. Similarly, for this particular constraint is also like this. So x1 minus 2x2 is equal to 1. So x1 is equal to 1 plus 2x2. So I can identify the range of values here. So if I put x2 to be 0, so x1 is equal to 1 plus 2 into 0, which is equal to 1. So x2 is equal to 1 plus 2 into 1, which is equal to 3. So x2 is equal to 1 plus 2 into 2, which is equal to 4 plus 1 is 5. So x2 is equal to 1 plus 2 into 3, which is equal to 6. Now for different values of x2, I get the x1 values to be like this. After this, we have to go for the graphical presentation. Now here in the graph, the same thing has been presented. Now what we should do is, if you identify the values here, the same thing is plotted. So the first constraint is 5 and 10, right? So if you observe here, so the first value is going to be here 5 10 and 5. So it will be 10, x1 is 10 and 5. Second one, it is 6 and 6. So third and fourth we have different values. How to plot that I shall let you know now. So here what I should do is, for the first constraint it is 6 and 6, correct? Then first constraint it is 10 and 5. So x1 is 10 and x2 is 5. So 10 and 5 I have drawn a line. Then the second one is 6 and 6, is it not? So the same thing is drawn here. Now if you observe here, what I should do is, I have to, for this particular constraint, x2 is started with 2 here. See 2 I have to plot here. Then 3 and 1 corresponding. Okay. The scale here is identified this way. Scale for OX axis 1 unit is equal to 2 units. OY axis 1 unit is equal to 2 units. Okay. So having done that, so what we should do is for each of these lines we have a plotted and a line is drawn. So here it is 2 0, then 3 corresponding value is 1, 4 and 2, so this is 1 point, then 5 and 3, correct? So after having worked out this, we have to draw a line connecting the points here. Similarly for this one also, it is x1 is 1 and 0, right? Then 1 and 3. x1 is 3, corresponding x2 is 3. So then we have 5 and 2, right? So what we have got to do is, here we have plotted, and 6 and 3, so it will be 6 and 3. So here what we should do is we have to draw a line connecting these points. So the constraint is just this. So x1 plus 2x2 is lesser than or equal to 10. So here, which is the a line which is representing this, we have to write it on the line. So this is x1 plus 2x2 is equal to 10. So here it is x1 plus x2 is equal to 6. Okay. Then the third constraint is x1 minus x2 is equal to 2. Right. So x1 minus x2 is equal to 2. Then here it is x1 minus 2x1 is equal to 1. So after having worked out all this, we have to identify the feasible region. So here it is given that it is less than or equal to 10. Is it not? The first constraint, all the constraints are less than or equal to. So here if you go by this, the area, shaded area will be this particular point where all the points are connected and they will be satisfying the all the conditions. Now here you got to do, remember one thing is that area below the lines x1 minus x2 is equal to 2 and x1 minus 2x2 is not desirable due to the reason that the values x1 and x2 are desired to be non-negative. So here if I go with this particular line, I will not be able to satisfy the conditions because you are under the negative continuum. So anything below this we get negative, right? So that will not be satisfying the conditions. So that is the reason that you will not take this particular region, since we have non-negativity restrictions, is it not? So we have non-negativity restrictions which need to be taken care of. So after this we can solve for the coordinates. So the coordinates will be 0, 0, 1 and 0, 3, 1, 4, 2, 2, 4, 0 and 5. So here we are having the objective function to be maximize z is equal to 2x1 plus x2. So if we solve this, z is equal to 2 into 0 plus 0, which is equal to 0. Then 2 into 1 plus 0, which is equal to 2. Then 3 into 2 plus 1, which is equal to 7. Then 2 into 4 plus 2. Then 2 into 2 plus 4. Then 2 into 0 plus 5. So these are all the values which are given. So here we are given the objective function to be maximizing. So your z value will be this. So the company has to produce x2 to be 4 and x1 to be 4 and x2 to be 2. So z is equal to 10 at extreme point 4 and 2. So therefore x1 and x2 are given to be this. So this is how we solve this particular problem. This is about this problem.